Hi, Thomas.
Hello.
How are you doing tonight?
I'm good. How are you?
Good. So what are we going to do tonight?
One second. I have a test on I think it's Wednesday.
Okay.
So I kind of want to get a study session in sooner
Alright.
than later. But I'm sending you the chat. In the chat, all the stuff I need to know.
Alright.
So if we could just go over each one.
Alright. Constant change in the graph of a linear equation. That line is y equal x plus 2. And because that's a straight line, the change is always the same no matter where you're at on this line. In other words, if you're here on the line is changing 1 unit up for every unit you go over. If you're here on the line is changing it 1 unit up for every line you go over.
Okay.
Okay? If you're looking at quadratics, notice that they're curved lines. In other words, if I look at this, now the rate of change changes dependent on where you're at on the x-axis. If you're over here, for every one you go over, it's going down. If you're right here, there's no rate of change, 0. If you're over here, for every one you go over, you go up. But the rate of change changes throughout the domain.
Okay. So that's not constant change.
That's exactly right. And that's the difference, is linear change is always constant change. Anytime the line is curved, it isn't constant.
Okay.
Okay, if we look at this curve, and we want to figure out how to graph that, what's the best way to graph that?
2x. 6. Is this still the constant change, or is this linear?
Yeah, this is still linear. Notice there's no x squared terms. In other words, we could solve this for y, and we could even put this into y equals mx plus b format. Easy enough.
Right.
We could graph it that way. But there's an easier way to graph it. And we should talk about it since it mentions it here. What is the graph of ax plus by equals c? Well, that's the form that I've written this. What is the x-intercept of that function?
It is...
What is y at the x-intercept?
Is this 2?
Y is always 0 on the x-intercepts.
Oh, right, yeah.
And x is always 0 on the y-intercept. So figuring out the intercepts are relatively easy here. If you want the x-intercept, plug in 0 for y and solve. What do you get?
Wait, so you plug in 0 for y?
Yeah, because notice that when I'm on the x-intercept, the y-coordinate is 0.
Okay, so then x is 3.
And to get the y-intercept, plug in 0 for x.
Which is 2. Or, oh yeah, y would be 2.
So to me, that's the best way to graph when you have it in standard format, which is that.
Okay, let me just write that down.
Just do the x and y intercepts, and then you don't have to manipulate this. Notice that if I solve this for y, I get 3y equal minus 2x plus 6, or y equal minus 2/3 x plus 2. Well, I know how to plot that. I start at the y-intercept, and I have a slope of negative 2/3. So I go down 2 over 3. So I can do it either way. It just seems to me that it's much simpler if you do the x and y intercepts.
Right.
And I got to think that that's what they're teaching you, is that the proper way to plot that is by doing the x and y intercepts. All right, what else you got here? Let's see, the graph of ax plus by equals c, we just did that. Finding an equation of a line, fitting a line to data.
Line to data. Wait, so the graph of x plus by, that's basically the same as linear combinations and
Well, now hold on.
x plus by.
What we just did was graph that linear equation that was in the form ax plus by equals c.
Okay.
We did it by finding the x-intercepts and the y-intercepts and graphing it that way.
Okay.
So now I'm going on to finding an equation of a line. Well, finding an equation of a line depends on what information they give you. Let's do a couple of things. I'll give you 2 points and you tell me the equation of this line. What's the first thing to get always?
The slope.
What's the slope here?
So the slope, 1 second. It's 7 minus 1 and over 4 minus 2.
Okay, so that's
6 over 2.
right. So that's 3. So now that we have slope, what do we do next to come up with the equation of the line? And there's 2 things you can do. You can use y equal mx plus b to solve it, or you can use the point slope format. Do you have to know point slope?
Yeah.
Well,
I
point slope is called point slope because it works whenever you have a slope and 1 point. So let's use it, as long as you know. What's the format for point slope?
It's y minus y1 equals m times x minus x1.
Pick a point, plug it in.
Okay, so
Remember, we only want 1 point. This is called point slope. So
I'll just do the first one. So it would be
okay.
So it would be y minus 1 equals 3 times x minus 2.
And that would be a sufficient answer unless they say, well, put it in y equal mx plus b format. So let's manipulate this further so that it's in y equals mx plus b format.
So, well, we have our slope. Oh, well.
Distribute the 3.
Okay.
What do you get?
3x minus 6.
Now move the 1 over.
Move the 1 over. Oh, you mean add 1 on both sides?
Uh-huh.
Okay. 3x minus 5. 3x minus 5. Oh, yeah. So that's
mx plus b format.
Okay.
Okay. And we could have gotten it using MX plus B format, but it's a little tougher. It depends on what the final format you want it in is. But no matter what the final format, you can use point slope and then convert it to that, just like we did there. Okay, so another way to say, come up with the equation of a line. What was that? That was y equals 3x plus 5. Give me the equation of the line that is perpendicular to this line and goes through the same point.
Okay, so a line that's perpendicular with this, well, it's going to have the same slope, I know that.
No, parallel is same slope.
Oh, right. Perpendicular is...
Perpendicular is what?
Is minus 3. Or
Negative reciprocal.
negative, oh yeah, so it's like 1 over 3 or something?
It's minus 1/3. You do the reciprocal and you change the sign.
Okay.
So the slope of the perpendicular is equal to minus 1/3. Okay, now let's use point slope again to figure out the equation of that line.
So, alright, so point slope. Oh yeah, because we already have our thing. So, okay, so it'd be y minus 1 equals, and then the negative 1/3, and then x minus 2.
And then once again, if we want to get that in y equal mx plus b format, we have to distribute the third. Move the 1 over. And there's your answer in mx plus b format. Then the other kind of question they might say would be, okay, give me the equation of the line that is parallel to this equation and goes through the point 3, 3.
Okay, so that would be y minus 3 equals 3 times x minus 3.
Okay.
So it's really all about the slope when you're kind of
it's always all about the slope, including when you get to calculus. That's why they put so much emphasis on slope, is because slope is almost the definition of first derivative in calculus. All right, let's see what else we have here. We've found finding an equation of a line. Okay, we've done that. Fitting a line to data. Let's talk about that for a moment. Let's say I have a table of data that translates to these points. And by that I mean when x is 1, y is 1. When x is 2, y looks to be about 2. When x is 3, y still is about 2. Okay, so in other words, it's just a bunch of points that are xy coordinates.
Okay.
And that's all the data you have. So if you want to come up with an equation, a linear equation, that represents this data the best, it clearly is going to look something like that. Agreed?
Yeah.
Maybe a slight variation, depending on whether you want to use this point as a final point. In other words, I could change the slope of that a little bit, and it would still look like a pretty good fit to those points. Well, when you do a linear regression, what kind of calculator do you have, Thomas?
I have the 84.
Okay, you can do linear regression on those.
Yeah.
You have to create two lists, list 1 and list 2, which are your x points and your y points. In other words, my x points here would be 1, 2, 3, 3.5, or 3.1, maybe 4, and so forth, and the corresponding y values.
Okay.
If you ask the calculator to do a linear regression of those points, it will fit a linear straight line through those points, much like I have done here, using a formula that is pretty much measures the perpendicular distance from each point to that line, squares it, and minimizes it.
Okay. Yeah, I remember doing this in class with the calculators.
Okay. And that's what linear regression is.
Okay. So it's just that, it's
That's
just finding that line?
fitting a line to data. That's what that is.
Okay.
Now, maybe that line looks more like that, slightly different slope, goes through the points a little different. The calculator is going to find the best fit for that data using an algorithm that it has. It's also not only going to give you the equation of that line, in other words, it's going to tell you the slope and the y-intercept, which is all you need for the equation of a line, but it's going to give you a number called r squared. R squared varies from 0 to 1, and a really, really good fit is almost 1. In other words, if I had these points right here in my table, well, you can see that when I fit a straight line to that, it almost goes through every single point. That's going to have this kind of r squared value. If I had a line that was a little more scattered, and I draw a straight line as best as I can through that, this r squared might be 0.7. You can tell that it's not as good a fit. It doesn't go through every point. There's a lot of distance from this point to that line. The sum of all of the squares of those distances is what determines this r value. That r value is the correlation coefficient. Biggest thing to remember is the closer it is to 1, the better that fit is.
Okay.
All right. Recursive form. Go ahead.
For a question, like if I had a question on a test for that, because I know we've done this with the calculator, would it ask for like the r value, or what would a question be like?
No, it would say find the linear regression for this set of points.
But, I mean, what would I write on the paper?
Yeah, the paper is going to word their question like this. Here's a table of x and y values. Find the linear regression that best fits this table. So you create list 1, you create list 2, and then you go to statistics and find the linear equation, and the answer you get is, okay, m is 2.1, and the other value, I don't even know what they call it, maybe they do call it y-intercept, is 4.6. So the equation is y equal 2.1x plus 4.6.
Okay.
So there's the answer. And your calculator has to give that to you. We don't have a way of doing that manually.
Right, okay.
Okay, so that's linear equation. That's linear regression. Let's talk about arithmetic sequences.
Is this like recursive and explicit formulas?
Uh-huh.
Okay, yeah, because I have trouble with these.
Okay, here is the explicit formula for an arithmetic sequence. A sub 0 is the first term in the sequence. N is the number of terms. And D is the common difference.
So that, wait, this is recursive or explicit?
This is explicit.
Okay.
Let's take a sequence. 2, 5, 8, 11, 14. This is an arithmetic sequence because it has the same difference between every two terms. That would be 3. So if I want the fourth term of this sequence, I can use this explicit definition. The fourth term, a sub 4, is going to equal a sub 0, which is 2, plus 4 minus 1 times the common difference, which is 3. So what is that? That is 2 plus 9. The fourth term should be 11. And it is.
Okay, so explicit is where they're even amounts apart.
No, well, no. That's not really the definition of explicit. That's the definition of an arithmetic sequence.
Okay.
You also have geometric sequences where the difference is a common ratio. In other words, if I had 2, 4, 8, 16, have you had geometric sequences yet?
I think we have, yeah.
Well, notice that every term is twice the previous term. Up
Okay.
here, every term is the previous term plus 3. So that's the difference between arithmetic and geometric. Let's keep talking about arithmetic for a moment, because this is the explicit, and the explicit always defines the nth term in terms of the first term and the common difference. If I want the recursive sequence, then the nth term is equal to the term prior to it plus d. In other words, if I want the fifth term, a sub 5, then I got to take a sub 4 plus 3. Well, there's a sub 4. Add 3 to that, and I get the fifth term. The recursive definition is always a function of the previous term, whether you have an arithmetic series or a geometric series. In other words, when I have a recursive, I know that it's going to be a function not of the first term, but of the previous term.
Okay.
Okay? Let's see what else we got over here. Maybe we should talk about geometric sequences. I don't know. Formulas for linear sequences. I'm not quite sure what you mean by a linear sequence. And I know a lot about sequences.
Did we do the graphs of sequences?
No, we didn't. And that's because in my book on sequences, there are no graphs of sequences.
Okay. Let me look at mine as well.
Okay, no, well, they're discrete graphs. In other words, if I were to try to make a graph of this sequence, yeah, I guess there are graphs. Here, we'll do this sequence that I've got at the top here. When n is 1, the sequence term is 2. When n is 2, the second term is 5. When n is 3, the third term, the sequence is 8, and so forth. So it's a scatter plot of dots, where your horizontal axis is the number of terms of the sequence, and your vertical axis is the value of the term.
Okay.
That's about all you need to know about the graphs of it.
That's pretty easy.
Yeah. However, some of the problems, we should do some problems with sequences. Let me look in my book here. I've got a few. Okay. One term of an arithmetic sequence is a sub 13 equals 30. In other words, the 13th term of this sequence is 30. The common difference is 3 halves. Write a rule for the nth term and graph it.
Okay. So write a rule for the nth.
Yeah, so always start with the explicit formula for a sub n.
Okay.
So a sub n is equal to what?
Is equal to, well, we don't really know though. Well, it's equal to
The general formula.
0 or a1.
A sub 0 plus.
Oh, there's a general sorry. Okay, yeah, it's plus n minus 1
Times the
d.
common difference. Okay,
Yeah.
now let's fill in what we know and see if we can solve for what we don't know. We know the 13th term is 30. So I know a sub 13 is 30, so I can write 30 there with n being 13. I don't know the first term, but I know n is 13, and I know the common difference is that. So that now allows me to solve for the first term of this sequence. What is it?
Okay. So you have to get the first term on one side.
Right.
So can you just
Let's solve this
subtract
equation.
it, or?
Well, let's solve this equation. What's the first thing you want to do?
I would subtract it from both sides.
Well, hold on. Let's start with parentheses. Think PEMDAS always.
Oh, yeah, sorry. Okay, yeah, so you you do the parentheses, so it's then 12.
Okay, and now multiply 12 times 3 halves.
12 times 3 halves. I'm not really sure.
Okay, this becomes 6, this becomes 1, so this becomes 18. So now we have 30 equals a sub 0 plus 18. So a sub 0 is equal to 12. That's your first term in the sequence. And in fact, if I was going to list out the sequence, first term would be 12. What would the next term be?
Then you would add on, well,
Add the common difference.
okay, add the common difference. And that'll give you the second term, and then
Exactly.
and so forth.
Exactly. So it's 12 plus 3 halves.
12 plus 3 halves. Sorry, I'm writing this down. 12 plus 3 halves. I'm not really sure. Yeah, 13.5. Oh, wait, no. Minus, yeah, 13.5.
What's the next term?
So then 13.5 plus 3 halves is 15.
And so forth. And if I were to continue that, the 30th, or excuse me, the 13th term is going to be 30.
Okay. Yep, I get that.
Okay. Now let me give you that. These problems can be structured many different ways. They did say graph this, so let's do a quick graph of it. Remember, this is n, this is a sub n. So when n is 1, that's 12. When n is 2, it's 13 and a half. When n is 3, it's 15. And that's it. That's the graph of sequences. Horizontal scale is n counting from 1 up, and the vertical scale is the nth term of that series, or sequence rather.
Okay. So you just start at your first term and then keep adding on.
Yes. That's arithmetic sequences. Let me give you another problem for the arithmetic sequence. Well, we didn't really finish that. We discovered that I didn't mean a sub 0, I meant a sub 1. In other words, a sub n is equal to a sub 1 plus n minus 1 times the common difference, okay? That's the explicit term. I was saying a sub 0. It's really proper to say a sub 1 because n starts out at 1, not 0.
Okay.
Well, given the information they gave us, we solved for a sub 1 is equal to 12. So now, what is the nth term?
The nth term.
Back to that.
Just, oh, wait, oh, so it's 12 plus, I get 12 minus 1, or, yeah, no, n minus 1.
No, we don't have n determined here yet. When I say the nth term, n can be 100.
Yeah.
But the only thing we know now is we know the first term and we know the common difference. So I can fill both of those in.
Okay.
So here's the formula for the nth term of this sequence, but it hasn't really been simplified yet. We can distribute this 3 halves. So we get 12 plus 3 halves n minus 3 halves, which is 10.5 plus 3 halves n. So there's the nth term of the sequence. No matter if I want the 13th term of the sequence, notice that I am going to get 30 based on this formula. If I want the 100th term of the sequence, it's going to be 150 plus 10.5. It's going to be 160.5. But notice how this looks different. In other words, it's always, the general formula is always n minus 1 times d. So when you know what the common difference is, you have to distribute this, and you end up with a final form that doesn't look like this. It's no longer n minus 1 times d.
Okay.
Okay. Let's do another one. If I have two terms of a sequence, arithmetic sequence, 6th term is 10, and the 21st term is 55. Find a rule for the nth term.
55.
Now this is a little tricky. I got to think you might have to do something this hard, though. Start with the general formula for a sequence, always.
Okay.
And let's write the best equation we can write based on that information.
So, well, it doesn't seem like we know anything.
Well, we know a sub 6 is 10. So
yeah,
what that
so we can
means
go that
is
way.
that when n is 6, this term is 10. So I can fill in 10 and 6 for n, so that becomes 5d. So I can write that much of an equation based strictly on that.
Okay.
Now let's write a similar equation based on that. What would
So
that
then we
be?
can do, this would be 55 equals A21.
A sub 1.
Oh, A sub 1.
21 means n is 21.
Oh, okay, yeah, sorry. And then plus, I don't really get this part, yeah.
Well, if n is 21, what is n minus 1?
54.
20. N is 21. N minus 1
Oh,
is
yeah,
20.
sorry.
And we don't know d yet. However, what we've just come up with is two equations and two unknowns. I can solve that. Let's set it up just like we would two equations and two unknowns. Well, let me take this equation and subtract this one. In other words, I'll call this equation 1, I'll call this equation 2. I'm going to subtract equation 2 from equation 1. That's going to eliminate the a sub 1's and let me solve for d. So 45 equals 15d. So d equals 3. Now, once I know that d equals 3, I can solve for a sub 1 in either of these equations. A sub 1 has to be minus 5. By plugging in 3 for d in this equation right here, I get 10 equals a sub 1 plus 15. A sub 1 has to be minus 5.
Okay.
So now, what is the equation for this sequence? I've figured out d, I've figured out a sub 1. So we want to go back to the general formula and substitute the two things we've solved for. So we want a sub 1 there.
Equals negative 5. plus it's 1 or 5 minus 1.
No, we don't have a 5. We don't have an n value.
Oh, yeah, yes.
In other words, when we give the general formula, what we usually have is that and that. So when we end up with a specific formula, we're going to end up with something like this, only we know D now is 3. Okay? So what I usually have to solve for is A sub 1 and D. Once I solve for them, then I go back to the general formula for A sub n. This is general because it'll work if I said, what's the 111th term in this sequence, you could tell me.
Just by plugging it in. Okay.
By plugging in 111 for n. So A sub 111 would be equal to minus 5 plus 110 times 3. Well, that's 330 minus 5, that's 325. So that is the 111th term in that sequence that begins minus 5, minus 2, plus 1, 4. Those are the first 4 terms of that sequence. The 111th term would be 325, but it'd be awful hard to come to that if I had to count them out. So I need this explicit way to come up with the nth term, whatever n might be.
Okay.
This was kind of hard because you had to come up with 2 equations and 2 unknowns and solve them, which not all sequence problems are going to have that degree of difficulty. And incidentally, we didn't reduce that yet. I kind of got off track there. In other words, this is not the final answer. We have to distribute that. Notice that after you distribute it, it always gives you a different formula. So this would be minus 5 plus 3n minus 3. So this is minus 8 plus 3n. So this particular sequence, the answer is this, not this.
Okay.
Okay, so even after you've solved for A sub 1 and D and plugged it into the general explicit formula, you still have to reduce it by distributing the D to the n minus 1.
All right.
So, same question. Find the value for n such that A sub n would be equal to 40.
So that it's, wait, when you just plug it in then? Right?
Uh-huh.
Okay, so 40 equals...
So let's do it this way. So A sub n equals 40, so I'm going to plug in 40 for that. Now figure out what n has to be. Solve that equation.
Yeah. It's 48 divided by 3.
16. So now what is the, oh, that was what they wanted, was the value of n for which A sub n was equal to 40. So what they're really saying is that A sub 16 was equal to 40.
Okay.
Okay. I'm looking for more here. Have you had the sum of a finite arithmetic series?
Finite.
First
It
of all,
doesn't sound familiar.
let's talk about the difference between sequences and series. A sequence is a string of numbers. There's a sequence.
Okay.
That's not an arithmetic sequence, and it's also not a geometric sequence, but it's nonetheless still a sequence. A series, on the other hand, is the sum of a sequence. So if I said, what is this series, you just add up all the numbers. And there is a formula for the sum of an arithmetic series. An arithmetic series, the sum is n times the first term plus the nth term all over 2.
So this is to find the series?
This is to find the sum of the series. That's really what series means, is sum. So if I said to you, give me the sum of the first 100 digits, in other words, 1 through 100, what is 1 plus 2 plus 3 plus 4 up to 100? Using this formula. What is S sub 100? Plug in everything you know.
Okay. So
N is what?
100.
A sub 1 is what?
A is 1
A sub
plus 2.
A sub 100 is what?
100.
There's your answer.
Okay, so what were we trying to figure out there, though?
The sum of all 100 numbers.
Okay.
In other words, what is 1 plus 2 plus 3 plus 4 up to 100? The S means the sum of that series. The sum of the first 100 terms. If I wanted the sum of the first 1,000 terms, I could get that by this same formula. Only this would be 1,000 and that would be 1,000.
Yeah.
And this would be 1,000. You probably got that, or if you haven't had it yet, you will. Merely because that's in my regular algebra book, in the arithmetic series section.
Okay.
Let's do one more. Yeah, this is all arithmetic series here. You haven't gotten into geometric yet, so we won't talk about those yet. But I can give you some interesting questions. Here is a series. Notice that when I say the word series, I put plus signs between each term, not a comma.
Okay.
This is not a sequence. This is a series. That means there's more terms in that series. When I put dot, 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 or actually it's one plus sign and then a bunch of dots. Find the sum of the first 30 terms.
So then you would do S30 equals 30 plus 4, or 4 plus 30 over 2.
Hold on a second. What is the 30th term going to be? It's not going to be 30. In other words, we need A sub 30. So in order to get A sub 30, we need to go back and use the explicit definition for the 30th term of a sequence, of an arithmetic series. Well,
Okay.
a sub n is equal to what?
A sub n is equal to a sub 1 plus n minus 1 times d.
Okay, we know a sub 1. We know n is 30, since we're trying to find the 30th term. And we know the common difference is 3. I can see that from looking at the series. So what is the 30th term?
So, 4 plus 29 times, or do we know the...
Common difference is 3. If you look at that series,
Okay, yeah.
each term is 3 from the other.
Right.
Okay, so that is, the 30th term is 4 plus 87, 91. So now, a sub 30 is 91. I plug it in for a sub n, because they want the sum of the first 30 terms.
Mm-hmm.
And I still have to divide by 2. So whatever 30 times 100, or 95 divided by 2 is the sum of that sequence. And got just about enough time to finish this problem, or to ask another question about this problem, which is, find n such that s sub n is equal to 175.
Okay, so we have to do that again to go back to the original equation.
Well, you always want to go to the general equation, which I've just checked at the top of this page.
Yeah, yeah.
This is the general equation. Let me erase some of the stuff that we don't need anymore. And their question is what n results in an s sub n equal to 175? So what gives 175 as that answer? And we're trying to solve for n, so we know that we don't know that yet.
And it's with the same series as below.
Uh-huh.
So then 4 plus n divided by 2.
No. We need a sub n.
So wait, so 175.
4 plus a sub n divided by 2 is going to be our answer. But notice that we got two variables here now that we don't know. We don't know n and we don't know a sub n. So
Yeah.
I can't solve this immediately, so I still have to go back to my explicit formula for a sub n. What is that again?
That is an equals a sub 1 plus n minus 1 times d.
It's 4 plus n minus 1 times 3, right?
Okay, yeah.
That's the explicit. We know our first term is 4. We know our common difference is 3. Well, if we distribute that out, we get 4 plus 3n minus 3, which is equal to 1 plus 3n. There is a sub n. So in place of this a sub n, I'm going to put 1 plus 3n. Now notice notice I have an equation with only one variable, n.
Okay.
And I can solve that by just algebraically manipulating that.
Yep.
Turns out that the n is 10. In other words, n of 10. This incidentally gives you a quadratic. When you go to solve this, notice we have n multiplied by another n. So we end up with a quadratic that we have to factor. We get a negative n and a positive n when we do that. And you only take the positive numbers. N cannot be negative.
Okay.
N is the number of terms. It's like coming up with a negative measurement for a garden. You throw it out. If you come up with a positive and a negative, the negative is the extraneous solution, and you use the positive number. Same thing with sequences. When you solve for n and you come up with a plus and a minus, the minus is not a good solution.
All right.
All right. You can come up with a lot of problems with sequences that are all a little different, but we're out of time, so I won't give you any more. But I got a lot to give in this book. If you want to do another, I don't know what will be on next session. Probably you're going to want to do geometric sequences.
Yeah.
That's the only thing they give you in Algebra 2, is arithmetic and geometric. There's lots of other kinds of series and sequences, but the two they start you out with are arithmetic and geometric.
Okay.
All right. Well, good luck on your test,
Thank you.
and I will talk to you next time, Thomas.
Yep. Sounds good.
Bye-bye.